This video explains how to delete a workpiece in the machine simulation. Open the included file work_delete_before.vcmx. Check that two workpieces, destination table, feeder, and robot are placed. Perform the simulation. A workpiece is generated from the feeder, and the robot transports it. Reset the simulation. Place a model from eCatalog to delete the workpiece by the following steps. Expand models by type and click Physics. Place product bin, Physics, into the 3D world by double-clicking or dragging and dropping it. Move it onto the table. With it selected, select Snap in the Tools group. Snap moves the selected item to the position where the component is clicked. Click the center of the table. Switch to the mode that deletes the workpiece as follows. In the Component Properties window, set Mode to Sync and Interval to 5. Perform the simulation. When the robot transports the workpiece and the simulation time reaches 5 seconds, the workpiece is deleted. The workpiece can be deleted at intervals from when the simulation is started to the number of seconds set to interval lapses. The intervals from when the workpiece is transported to when it is deleted cannot be specified. The following explains how to wait for a specified time after the workpiece is transported and delete the workpiece. Reset the simulation and delete product bin, Physics. Add settings to the table to delete the workpiece after detecting the workpiece at the transfer destination and waiting for 5 seconds by the following steps. Select the table and then the Modeling tab. A sensor to detect the workpiece to be deleted needs to be added. Set the sensor position. Click Features in the Geometry group and select Frame of Other. A frame is a reference point that defines the position and direction in the 3D world. When the frame is not displayed in the 3D world, click Frame Types on the toolbar of the 3D world and select the checkbox of Frames. When the icon is transparent, frame type is disabled. Click the icon to enable it. The frames are displayed in the 3D world. To move the frame, enter 300 for the coordinate y, 500 for the coordinate z, and 90 for the coordinate ry in the Feature Properties window. To detect the workpiece, add a sensor. Click Behaviors in the Behavior group and select Raycast of Sensors. A raycast sensor emits a light beam from a defined frame position and can detect components that cross the light beam. Define the sensor position by selecting a frame. Select Frame in the Properties window so that the light beam can be emitted in the +Z direction of the selected frame. Set the length of the light beam and the range to detect the workpiece as follows. For max range, set the range that the distance between the sensor and the detected component can be measured. For range signal, define a real data type signal so that the distance can be output. The distance is not measured this time, however, set max range to 200 to change the length of the light beam displayed in the 3D world. For detection threshold, set the range that the component can be detected. Change the value to 200. To hide the light beam, deselect the checkbox of Show Ray. To display the light beam, select the checkbox of Show Ray. Select the checkbox here. For component signal, define a signal that stores a detected component as a value. To acquire the component detected by the sensor, add a signal. Click Behaviors in the Behavior group and select Component of Signal. The component signal can send and receive the component as a value. In the Component Graph window, select Raycast Sensor. In the Properties window, select Component Signal from the drop-down selection of Component Signal. To delete the workpiece, add Python script. Click Behaviors in the Behavior group and select Python script of Miscellaneous. The Python script editor window opens. Delete the source code written by default except for the first line. Write comp equals get component parentheses to acquire information of component including the Python script. Write signal equals comp.find behavior to refer to the behavior of the component. Write component signal in parentheses so that the behavior whose name matches is referred. Write def on run parenthesescolon to execute a program when the simulation is started. Write while true colon to loop the following program. Write trigger condition lambda along at trigger parentheses equals signal so that the program will not be executed and wait until the component signal value changes. To execute the program when the component is stored in the component signal value, write in signal.value equals none. To define the component detected by the sensor as a workpiece, write work equals signal.value. To wait for a specified time before executing the program after the sensor detected the workpiece, write delay parentheses. Write 5 in parentheses to delay the program execution for 5 seconds. To delete the workpiece, write work.delete parentheses. Click Compile in the upper left of the window. To use component signal as a trigger in the trigger condition written in the Python script, connect to the Python script. In the Component Graph window, select Component Signal. In the Properties window, click Connections to display the plus icon. Click the plus icon and select Python script in the Add Connections Items window. Close the window. Perform the simulation. You can see that the workpiece is deleted after the robot transported the workpiece and 5 seconds elapsed. Caution must be taken when using the delete function of Python script. The deleted component cannot be restored by clicking the simulation reset button or pressing the Ctrl key and Z key. Reset the simulation. Open the Home tab. Select Feeder to swap the positions of feeder and work A. In the Component Properties window, enter 1000 for the coordinate Y. Select work A. In the Component Properties window, enter 0 for the coordinate Y and 600 for the coordinate Z. Perform the simulation. Work A is deleted. Click the Simulation Reset button or press the Ctrl key and Z key. Work A cannot be restored. There is a method to hide the component and simulate the delete processing without actually deleting the component. Select Work B. In the Component Properties window, enter 0 for the coordinates X and Y and 600 for the coordinate Z. Select the Table and then the Modeling tab. Double-click on Python script in the Component Graph window. Change work.delete parentheses to work.visible equals false. Click Compile. Perform the simulation. The workpiece appears to be deleted, however, if you check the Cell Graph window in the Home tab, you can see that work B is hidden. This is the end of the explanation of how to delete the workpiece in the machine simulation. Thank you for watching.